Now we are going to prove some real number problems. For that first problem, prove that the root 3 is irrational. We are going to prove this by contradiction method. So contradiction method is first one we are going to assume on data, and finally we are going to give the contradict that. That is that our assumption is wrong. So we can tell that thing is correct. So assume that root 3 is rational. We need to prove irrational, no? So assume is rational. Now root 3 equal to r by s, where r and s are integers. Suppose r and s are have a common factor other than 1. Suppose 2 comma 4, 2 divided by 4 we can write as the simplest form 1 by 2. You have a common number 2. Suppose 7 and 77, it's also rational number, so common number 7, so we can cancel by 7, so 1 by 11 divide by the common factor. So now we are going to write let root 3 equal to a by b, where a comma b are coprime. Now using the product we are going to write root 3 into b equal to a, that is a equal to root 3 into b. Swipe square on both sides, we get a squared equal to root 3 into b the whole square, that is root 3 squared into b squared. So a squared equal to 3 into b squared. A squared is divisible by 3. So a squared equal to product of 3, no? So that is a squared equal to 3 into some number. So a is suppose 12. So definitely 12 we can write as 4, no? That is 12 we can divide by 3. So that thing is given. A squared is divisible by 3. We can divide this 12 by 3. Like that you can get the own examples. So by the theorem we have let p be a prime number. Suppose p be a prime number. If p divides a squared, then automatically p divides a. If p divides a square, that is 3 divides a square means 3 definitely divide a. This is the theorem where a is some integer. So now a is divisible by 3 automatically. By theorem, no, a square is divisible by 3, a is divisible by 3. Let a equal to, a is divisible by 3 means 12. That is we return this 12 equal to 3 into 4. 3 into, where c is some number, instead of c we can get write 4. That is 21 we can write 3 into 7. 15 we can write 3 into 5. Something, no. So now this is the multiple of, a is multiple of 3. So that's why 3 into some number. C is some number. Don't think that it's a variable. It's some number. Now we are going to substitute this thing in your given data. That is a squared equal to 3b squared. So 3b squared equal to substitute a squared value. That is a equal to 3c. Substitute. So 3 squared c squared. So 3 squared value 9. So we divide by 3. So b squared equal to 3c squared. Now b squared is divisible by 3. By theorem we can write b is divisible by 3. That is both a and b is divisible by 3. So but our assumption is already a and b are co-prime. No common factor. But here we have common factor. A and b have at least 3 as a common factor. This is contradict our assumption a and b are co-prime. That is our assumption is contradiction. So it's wrong. That is therefore root 3 is irrational number. Our assumption is root 3 is rational, no? So this is a contradiction. Root 3 is irrational number. Using the same thing you can prove root 3 is irrational. Instead of root 3 you have 2. Instead of 3 you have 5. So that's all. That is in root 2 we have root 2 equal to a by b. Next a equal to root 2 into b, taking square on both sides. So a squared equal to 2b squared. That is a squared is divisible by 2. That is a is divisible by 5. Divisible by 2. Now that is a equal to, we can write some 2c. Substitute here. That is 3b squared equal to 2c the whole square, 2b squared equal to, substitute a equal to c, 4c squared. So b squared equal to 2c squared. So b squared is divisible by 2, that is b is divisible by 2. So both a and b divisible by 2 we can write. So as it is the same problem, no, root 3. Using this, try this one. Similarly, root instead of 2 we have 5. That's all. Here 2c, no, here we need to take 5c. So 5 is divisible by B, A is divisible by 5 and B is divisible by 5. Like that you can write. Chain 3 equal to 2 and 3 equal to B, 3 equal to 5. You can prove this problem. Right. Next problem. Suppose A plus B, some root 2, some root 3, some root 5, some root 7, some A and B are some number is given, means now we are going to prove this problem using contradiction method. Assume that 5 minus root 3 is a rational number, that is 5 minus root 3 equal to r by s, where r and s are integers. Suppose r and s have a common factor other than 1, divided by the common factor, that is 5 minus root 3 equal to a by b. Already as it is given previously. Now 5 minus a by b, that is swipe, or just we can write this thing at left side, this thing in right side. So 5 minus a by b equal to minus root 3, we can write plus root 3. So root 3 equal to 5 minus a by b. So root 3 equal to 5b minus a whole divided by b. Now we know that a and b are integers, no? So integer means 5, 3, 2, minus 1, minus 2, like that any one number. Suppose a equal to 2, b equal to 3. 5b, that is 5 into 3 minus a 2 divided by b equal to 3. So 15 minus 2 divided by 3, that is 13 divided by 3. 13 divided by 3 is rational. Any p by q form. So rational number, you know that p by q form, where q not equal to 0, p and q are integer. So that is, this thing is rational number. So a comma b integer, that is this 5b minus a divided by b is rational number. But the root 3 is rational number. This implies root 3 is rational number. So this is contradict the fact that root 3 is irrational. So already we proved root 3 is irrational. Okay. Now we consider this root 3 is irrational. No. Suppose the question is show that 5 minus root 3 is irrational, means first we need to prove root 3 is irrational, and after that we need to start the proof of this 5 minus root 3. But show that 5 minus root 3 is irrational given that root 3 is irrational, means we can use directly. Otherwise we need to prove root 3 is irrational. Okay. Our assumption is 5 minus root 3 is rational is contradict, that is 5 minus root 3 is irrational. Next problem. Show that 3 root product a plus b root 2, a plus b root 3, a plus b root 5, a plus b root some number. Here instead of a plus b root 2, here no a. So that is the same thing. Using contradiction method, assume that a 3 root 2 is rational. This is rational. That is, let 3 root 2 equal to a by b, where a comma b co-prime. Root 2 equal to a divided by 3, no, into 1 by 3. So a divided by 3b, where a comma b are integers. A divided by 3b is rational, because a divided by 3b rational. Why? A one number, you can take any number, 1000. 3 into b, suppose 5000. After cancellation, this, because a comma b already co-prime, not possible, no. So that is 5 divided by 3 into bb 17. So 5 divided by 51. It's a rational number, no. So like that, a divided by 3b is rational. So this implies root 2 is irrational. So this is contradiction to our assumption 3 root 2 is rational. So 3 root 2 is irrational. So already we discussed, if root 2 is irrational, if root 2 is irrational given, means it's correct, otherwise it's wrong. Right. Therefore 3 root 2, otherwise we need to prove root 2 is irrational. So this is contradiction to our assumption 3 root 2 is rational. So 3 root 2 is irrational. The same thing. Show that 3 plus 2 root 2 a plus b, the same thing already proved here, plus that's all. Using contradiction method, assume that this 3 plus root 2 is rational, that is 3 plus root 2 root 5 is equal to a by b, where a comma b co-prime. Now keep it root term in left side, remaining all are right side. So a by b minus 3 LCM b. So a minus 3b divided by b. Now root 5 here, 2 its product, no, so 2 we can write as 1 by 2, that is a minus 3b divided by 2b. Already we discussed this is a, b are integers, no, so the division definitely no square root form, so it's a rational number. So it's a rational number, but left side it's a irrational number, that is it gives that one side is rational, that is this thing already definitely rational, that is root 5 is rational, but root 5 is irrational number. Therefore this is contradiction to our assumption. 3 plus 2 root 5 is rational, therefore 3 plus 2 root 5 is irrational, right? Show that 1 by root a is irrational. Using contradiction method, assume that 1 by root a is rational. The same thing, 1 by root a equal to a by b, where a comma b co-prime. So using cross multiplication method, b equal to a root 2, b into 1 b, a into root 2, or taking reciprocal on both sides, 1 by root 2 equal to a by b, no, so root 2 divided by 1 equal to b by a, that is root 2 equal to b by a, or this thing. So by using cross multiplication you can write. So root 2 equal to b by a, where a comma b integers. So b comma a is integer, so this is b comma a, b divided by a is a rational, b divided by a is a rational, we discussed it earlier. Why it's suppose 2 is a rational number, no, reciprocal of 2 is, we can write 2 as 2 by 1, that is reciprocal is 1 by 2. Now 1 by 2 is a rational number, like that. 7 by 10, it's a rational number, we know that. The reciprocal of this thing is 10 by 7. So 10 by 7 is also a rational number. So root 2 is a rational number, but our contradiction, root 2 is an irrational number, no. So this is contradiction to our assumption. 1 by 2 is rational, therefore 1 by root 2 is irrational. Using this you can prove 7 root 5, 6 plus root 2 is irrational number. Thank you.